Here we're going to look at example 4, where we identify a transformation based on a graph. So the given graph is a transformation of the parent cubic function. So let's make sure we remember that this is going to be y equals x cubed, or f of x equals x cubed. And how can we determine the equation of the graph? So we need to look at some changes here, and hopefully you've reviewed example 3 already, and we talked about our a, h, and k values. So we're going to be looking for something in this form here. Okay, we're looking at vertical and horizontal shifts, potential reflections, stretches, and compressions. Now, they're going to be nice to us here. There is no stretch or compression. Those are always the hardest ones to determine. For these type of problems that we're going to be working on in class, there will not be stretches or compressions. There could be a reflection, but we're not going to worry about stretches or compressions at this time. So how can we determine the equation? Well, we know that the parent function is y equals x cubed. So what have we changed from here? Well, parent functions y equals x cubed tend to look something like this. So the parent has n behavior of down up. However, our graph here, if I take away that parent function, let's just erase that for a second, my n behavior in this case is up down. So my graph, let's write this in red. My graph has n behavior of up down, which is the opposite of what we're used to with a parent cubic function. So that tells me my graph has been reflected. So as n behavior up down, that means it's been reflected. That's not how you spell reflected. So my y equals x cubed is going to be y equals negative x cubed. Remember, that's how we would reflect the graph. We'd have a negative value in there. Okay, so that's the first thing I want to look at. Next, I want to ask myself the origin of that original function, right? Where did that origin go? Well, that origin looks like it went left 4 places and down 1. All right, so we have a shift. So we shifted to the point, that point is -3, -1. So let's look at the left 4. So the second point, we had a shift 4 units left. And we should remember that that affects our h value. So this term up here in parentheses. So that means I'm going to have y equals negative. My x will be in parentheses, this will be cubed, and I need to do something to my h value right here. Well, remember, if it's going left, we're actually going to write that in as an addition or as adding. So we're going to add a 4. I'm sorry, not a 4. What am I doing here? I can't count. That's a problem. This went left 3 places, sorry. So shift 3 units left. So we're going to add a 3 here. I don't know where I got that 4 from. But anyway, we shifted left 3, down 1. So I wrote the right point. I just clearly counted wrong. So our h value will be a +3. So that gives us that shift left. And then we also need to show that shift, let's make sure we're using the right number, shift 1 unit down. So we're going to take our y equals -x + 3 cubed. And we need some kind of value for our k, all right? So that'll be either plus or -1. Remember, k values are straightforward. If you're going up, you're adding. If you're going down, you're subtracting. So in this case, we are subtracting 1. We're going 1 unit down. We've covered the reflection. We've covered the shift left. We've covered the shift down. So we're done here. Remember, for these type of problems, it is possible to have stretches and compressions in these, but for our class, our examples, there will be no stretches or compressions that we'll have to work with and worry about. Just worry about reflections and shifts left, right, up, down. So my final answer, it says, how can you determine the equation of the graph? The given graph, we're trying to find the function. our function would be y is equal to x plus 3 cubed minus 1. So look to see where the origin moved and look to see if there is a reflection. Sorry about that for fiasco there, but we're moving 3 units left, not 4 units left. Take your time with these. You really can't make drastic mistakes unless you're careless, kind of like I was, where I put the wrong number in. It's always going to be pretty obvious whether it's going left or right, up or down, and then you just have to be very aware of whether there is or is not a reflection. And that's all. Try the try it problem, and you should be good from there.